Today we want to begin the process of solving trigonometric equations. But before we do that, we want to look back and see what is a trigonometric equation saying. And we saw this very basically last chapter in chapter 4. Here, the cosine of x equals 1/2. That is the most basic trig equation. And what is it saying? Well, that cosine of x equals 1/2 is saying what angle measurement produces a cosine value of 1/2. This x here, or sometimes they're thetas, indicate the angle measurement. So if I were to have, for example, the tangent of 30 degrees, we know that's square root of 3/3. Tangent of 30, the angle measurement is attached with the tangent. Here we want to know what angle measurement produces a cosine value of 1/2. And the way we go about solving that is we use inverse functions, or as we also called in the previous chapter, arc functions, or the arc trig that we dealt with. So just as a review, where are the following inverse functions defined? Notice the word functions, sine, cosine, and tangent functions. So for sine, we're looking at the sine inverse or the arc sine. And if I looked at the 4 quadrants that the arc sine or sine inverse is defined upon, it is going to be the first and the 4th quadrant. We said it was defined from negative pi over 2 to pi over 2. That's once again for an inverse function. Once again, that function word is important. The second one, the cosine inverse or the arc cosine, was defined in the first and the 2nd quadrant, or from 0 to pi. Once again, the cosine inverse function. And then finally, the tangent inverse function was tangent inverse or the arctan. And that one was also defined in the 1st and the 4th quadrant, just like sine. And once again, that is the function. So let's solve the cosine of x equals 1/2 using the unit circle. And notice I say using the unit circle here because I need to find all solutions. So I want to know what angle measurement produces a cosine value of 1/2. So I pull out my unit circle, and remember the cosines are the x values. So I'm looking around the unit circle for all x values that are a positive 1/2. And I see an x value of positive 1/2 here at pi over 3, or 60 degrees. And I also see a positive 1/2 down here at 5 pi over 3, or 300 degrees. So inverses from the unit circle, what angle on the unit circle produces a cosine value of 1/2? Well, that's going to be pi over 3 and 5 pi over 3. However, if we use the calculator and I go and I plug in my inverse, let me put this as 60 degrees and 300 degrees so you can see that there. If I use my calculator for the cosine inverse of 0.5, you can see I only get one answer. I only get the 60 degrees. So if we use the calculator, what issue do we run into? We're only going to get one solution. And the one solution is going to be from whatever quadrant the cosine inverse or the tangent inverse or the sine inverse is defined in. So we only get one solution from the portion of the inverse function that is defined. So here when we looked at the unit circle, we saw pi over 3 and 5 pi over 3 both produced a cosine of 1/2, the first and the 4th quadrant. But we didn't get this 4th quadrant answer from the calculator because the calculator only works with the functions of trig inverse functions. So I only got the 1st quadrant answer and not the 4th quadrant answer. So you're only going to get one solution with the calculator. So we're going to have to come up with a process in order to solve. And if we use the calculator, our process has to be 2 steps. First, we are going to find the first solution using the calculator. And then second, we're going to find the second solution using a reference triangle. So we're going to find the first solution using a calculator and then finding the second solution using a reference triangle. And we're going to use this when we don't have values on the unit circle, this procedure. If we do have values on the unit circle, we can just use the unit circle. So the example down here, the sine of x is equal to square root of 2 over 2. Using the unit circle, solve the following on the interval. So what this is asking is, what angle produces a sine of square root of 2 over 2? Now we know that sine are the y values on the unit circle, so I want to find all the values that are sines where the answer is square root of 2 over 2. And we know sine is going to be positive in the first and the second quadrant. So if I look at my unit circle, I'm going to look at the y values for this, and I can see right here, here's a y that's square root of 2 over 2, and over here is the y value that's square root of 2 over 2, positive in the first and the second quadrant. So pi over 4 and 3 pi over 4 are the 2 angle measurements that produce a sine of square root of 2 over 2. The second one here, the tangent of x is equal to negative square root of 3 over 3. I want to find what angles produce a tangent of negative square root of 3 over 3. So here I can see tangent is going to be negative, and we know tangent is negative in the second and the fourth quadrant. So we'll go back to our unit circle and we look for tangents of negative square root of 3 over 3. I said we're going to be negative in the second and the fourth quadrant. So here's my negative square root of 3 over 3 in the second quadrant, which is 5 pi over 6. And then my negative square root of 3 over 3 in the fourth quadrant is at 11 pi over 6. So the 2 values for x are going to be 5 pi over 6 and 11 pi over 6. So when we're solving these trig equations, our answers that we're solving for are going to be angle measurements. The whole purpose here is trying to find the angle measurement. And once again, if we use our calculator, the issue we come across is that we only get one solution. The solution that the calculator gives us that is in the defined portion of the inverse functions.